This is a review for quiz 1. It covers the prerequisites and chapter 1. So number 1 is simplify completely. -6 is in parentheses and then squared. That's the same as -6 times -6, which means it is positive 36. Double negative yields a positive result when multiplying. Part B, we have a negative outside of the parenthesis and then -x inside the parenthesis squared. What that means is -1 times -x squared, or -1 times -x times -x. So that -1 times two negative x's, that actually will leave that negative out front, and x will be squared. Compare it with part C, where -x without the negative on the outside is squared. Well, that's just -x times -x, or positive x squared. Now, part D, slightly different, 5x cubed, and then everything is in parentheses and then squares on the outside. That just means that square applies to both 5 and x cubed. So it's the same as 5 squared times x cubed squared. So 25, and then x cubed squared is x to the 6th power. Now part 2, or example 2, simplify completely. Exact answers, please no decimals. So on this one, part A, we have 5 times -2, that's -10, and then we have x cubed times x to the 4th. Remember, we add the exponents, so -10x 3 plus 4 is 7. Square root of 20, well, that's the same as 4 times 5, which means that's the square root of 4 times the square root of 5. The square root of 4 is a perfect square, 2 times the square root of 5. -4x cubed, everything is to the 0 power. Well, anything, including expressions, to the 0 power is just 1. And since everything is inside the parenthesis and the 0 power is outside of the parenthesis, the whole thing just becomes 1. Now, part D, I have 3 on the outside of the square root and then 32. We have to simplify the square root of 32. 32 is 16 times 2, so that's 3 times the square root of 16 times the square root of 2. 3 square root of 16 is 4 times the square root of 2, and then 3 times 4 is 12, square roots of 2. All right, now, the third one, we're still simplifying completely. This time it's multiple expressions. On the first one, we just have to subtract, but before that, we have to distribute this negative sign to everything inside the second parenthesis. The first parenthesis can just be dropped. 4x squared plus 7x minus 3 minus 6x squared minus 3x plus 5. Now, like terms, I have the numbers with the x squared attached. 4 minus 6 with x squared, that means -2x squared. Then I have just the x's, plus 7 minus 3, that is positive 4x. And then I also have just the numbers without the x's, -3 plus 5, that's plus 2. Part B, we are distributing 2x squared to everything inside the parenthesis. So that's 5x cubed times 2x squared minus 8x to the 4th times 2x squared. 5 times 2, 10. X cubed times x squared. We're adding the exponents. That's x to the 5th. Minus 8 times 2, -16. X to the 4th times x squared. Adding the exponents. That's x to the 6th. Number 4, we're multiplying and then simplifying. So this is a double distributive property or a FOIL method. Either way, it's doing the exact same thing. So 3 times 2, and then 3 times 7b, and then negative 5b times 2, and negative 5b times 7b. Okay, 3 times 2, that's 6. 3 times 7b, that's 21b. Minus 5 times 2, that's negative 10b. Minus 5 times 7, that's negative 35. B times b is b squared. You should have like terms in the middle. So this is 6 plus 21 minus 10, that's positive 11b, and then minus 35b squared. Part B, 5x minus 2, in parentheses, everything is squared. This is a very, very common problem and also a very common mistake. Now, please do not just square the first term and just square the second term. That's not how it's done. You have to remember that 5x minus 2 squared is the same as 5x minus 2 times itself. And then you can do the FOIL method or the double distributive property and do like terms to actually do this question correctly. So 5 times 5, that's 25. X times x is x squared. 5 times negative 2, that's negative 10x. Negative 2 times 5, that's another negative 10x. Negative 2 times negative 2 is a positive 4. Now let's take care of the like terms in the middle. So this is 25x squared minus 20x. They both have a negative sign, so you add them together, keep the common sign, plus 4. All right, now factoring. So we have x squared minus 11x plus 30. Since there's no number in front of x squared, both parentheses will start with an x. Then we are looking for two numbers. One goes here, one goes here. Those two numbers multiply to 30. Now let me go ahead and make a note of that. Multiplying to 30, and we're adding to negative 11. So there's really only one possibility here. This is 6 and 5. Let's figure out the signs. So they have to add to negative 11. That means that both 6 and 5 have to be negative. But negative 5 times a negative 6 actually does give you a positive 30. So this is fine. Let's go to part B. We have x squared minus 4x minus 12. And again, there's no number in front of x squared. So we can go ahead and just put both parentheses starting with an x. We are looking for two numbers. They multiply to negative 12 and they add to negative 4. 3 and 4 are not going to work because they are not going to add to negative 4. So we have to figure out other possibilities. 6 and 2. Let's figure out the actual signs. Now, when I'm adding them together, they have to give me negative 4. So negative 6 plus 2 would give me a negative 4. Let's go ahead and check the multiplication. Negative 6 times positive 2 is negative 12. So this should work fine. We're still factoring in number 6. This time, you need to take out the greatest common factor before actually factoring the expression. So 5x squared plus 25x minus 70. If you notice that 5 is the common factor, you can take it out. X squared plus 5x minus 14. And now you're not done. You still have to factor the expression inside the parentheses. X squared plus 5x minus 14. We're looking for two numbers that multiply to negative 14 and add to 5. That would be 7 and 2, positive and negative. Negative 2 times 7, that's negative 14. Negative 2 plus 7 is positive 5. So this would be the final factoring. On part B, the greatest common factor is 6. So you're going to take 6 outside of the parentheses. That would be x squared minus 3x minus 4. Not done. We still have to factor the expression inside the parenthesis. Two numbers that multiply to negative 4 and add to negative 3. That would be 4 and 1. 4 would be negative and 1 would be positive. Number 7, we're working a lot with functions in this class, so we need to go ahead and figure out how to work with function notations. That's what this is testing. You're given 3 different functions. You need to find f evaluated at negative 3. Well, what you need to remember is that negative 3 represents your x. So x equals negative 3. So you're going to go to the function f and replace all the x's with negative 3. So this is 2 times negative 3 minus 3. Order of operations, you have to multiply first. So this is negative 6 minus 3. And now you can add these together, negative 9. All right, let's try h at 6, the same kind of thing, but with a different function. So function h, and we're plugging in 6 where we see the x. Absolute value, 2 over 3 times 6 minus 20. Okay, absolute value. You could just reduce as you're working this out. So the 3 and the 6, that's a 1 and that's a 2. 2 divided by 3, 6 divided by 3 is 2. 3 divided by 3 is 1. So now that's 2 times 2, which is 4 minus 20, absolute value. So that's the absolute value of negative 16. Well, the absolute value of a negative number is just a positive number. So 16 is your final answer here. Now, last function, g at 2. So again, take the function g, replace the x with the 2. So this is negative 3 times 2 squared minus 2. Negative 3, order of operations, I have to square first, times 4 minus 2, multiply. Negative 12 minus 2, negative 14. Number 8, we are calculating the x and the y intercepts and then using those intercepts to graph the line. A lot of the times the intercepts will need to be written as a point, so that's what we're going to do here. The x-intercepts, well, they happen when y is 0. So 2x plus 6 times 0 equals negative 18. 2x, 6 times 0, 0, equals negative 18, which means x equals negative 18 divided by 2, which is negative 9. If we want to state this as a point, negative 9 for the x, 0 for the y. So negative 9 for the x, 0 for the y. That's this point right here. I'll go ahead and switch color here. For the y-intercept, x will be 0. So this is 2 times 0 plus 6y equals negative 18. 2 times 0 is 0, so this is just 6y equals negative 18. Divide by 6, y equals negative 18 over 6, or negative 3. If you want to state this as a point, that's 0 for the x-coordinate and negative 3 for the y-coordinate. 0, negative 3, that's right here. And then in order to actually graph it, you would have to connect the dots with a straight line, or as straight as you can. Number 9, Hong wants to save $500 to buy a TV. He saves $17 each week. The amount that he still needs after W weeks is given by the following function. A of W equals 500 minus 17W. We need to figure out how many weeks he has been saving if he still needs $194 to buy that TV. So on this one, A is 194. We need to know how many weeks he has been saving. So we're going to plug in 194 for A and solve for W. First, you're going to subtract 500 from both sides. 194 minus 500 is negative 306. And then you're going to divide both sides by negative 17, leaving you with W equals 18 weeks. Part B is a little bit easier. On part B, we need to know how much money does he have after saving for 7 weeks. So in this case, W is 7 and A is what's unknown. This is a more straightforward approach where you just plug in 7 for W and then put it into your calculator. So $381 is what was saved after 7 weeks. Number 10, another applied problem. Small publishing company is releasing a new book. The production cost will include a one-time fixed cost for editing and an additional cost for each book that's printed. The total cost is given by the function c of x equals 550 plus 1595 times n, where n is the number of books. The total revenue from selling the books is given by a different function. R of x equals 34.6 times n. Let the profit be the profit made in dollars, then write the equation relating the profit to the number of books that is being published and then sold. The profit equals R minus C, so that's revenue minus cost. Simplify your answer as much as possible. Since the equation is actually given to us, that makes things a little bit easier. P equals R minus C. Revenue is this equation right here. So this is 34.6, and this is your R minus your cost is also given. The only thing that you have to remember is put the cost in parentheses. Since it has multiple terms, we'll have to distribute the negative in front. 550 plus 15.95 times n. And then simplification. So first thing you're going to do is distribute this negative to everything inside the parenthesis. So you'll have 34.6 n minus 550 minus 15.95 n. And then it's just combining like terms. 34.6 n minus 15.95 n. So that's 18.65 times n minus 550. And that is your equation for profit. Number 11, owners of a recreational area are filling a small pond with water. They're adding water at a rate of 20 liters per minute. There are 700 liters in the pond to start with. Let W represent the total amount of water in the pond, and T represent the total number of minutes that the water has been added. Write the equation relating W to T. Now, in this one, we don't need to do any calculations. We just need to create an equation. Since we know we're in chapter 1 and we're studying linear functions, the equation will be a linear equation. Our normal way to write a linear equation is to use the slope-intercept form. Y equals mx plus b. Now, m is the slope or the rate of change of something, and b is the y-intercept. Well, the y-intercept happens when the x is 0. So for us, 700 liters in the pond to start. That means at the time 0, we had 700 liters already in the pond, so B is 700. Now, the rate of change is 28 liters per minute. M is the slope or the rate of change. So M is 28. So all you have to do is use the correct letters and plug in the correct numbers. So for us, we're relating W to T. So the amount of water in the pond to time. Water equals, we're starting with 700 liters. We're filling the pond, not draining it, so we're adding water, so plus. We're adding water at a rate of 28 liters per minute. So after 1 minute, it's 700 plus 28. After 2 minutes, it's 700 plus 28 times 2, and so on. So we have to add a variable next to 28. And this would be your final equation using the correct letters. Number 12 is back to working with functions. We have two functions defined, r of x equals 4x plus 6 and s of x equals 3x minus 1. We need to multiply those two functions together, subtract them from each other, and then add them together and evaluate them at -1. We'll start with part A. We have s times r evaluated at x. It's not times x, it's evaluated at x. So that is the same as s of x times r of x. The function s of x is 3x minus 1. So 3x minus 1 times the function r is 4x plus 6. Then you have to FOIL this and do like terms to simplify it fully. 3 times 4 is 12. X times x is x squared. 3 times 6 is 18. There's still an x attached to it. -1 times 4, that's -4x. -1 times 6, that's -6. The like terms in the middle, 18x minus 4x. Everything else gets rewritten. 12x squared. 18x minus 4x, it's plus 14x minus 6. This is the final answer for that question. Let's try, I'll do part C first. S minus R evaluated at x, so that's the same as S at x minus R at x. S is 3x minus 1 minus R is 4x plus 6. The first parenthesis can be dropped, 3x minus 1. The second parenthesis, you need to distribute the negative sign to both things inside the parenthesis. So that's -4x, -6. Well, that means that when we're combining like terms, 3x minus 4x, that's -x, and then -1 minus 6, that's -7. Okay, and then s plus r evaluated at -1. Well, in this case, this is s evaluated at -1 plus r evaluated at -1. So take the function s, replace the x's with -1. So we have 3 times -1 minus 1, that's s at -1, plus 4 times -1 plus 6, that's r at -1. So in the first bracket, we have 3 times -1, that's -3 minus 1. In the second one, -4 plus 6. So that's just -4 plus 2, or -2. Number 13, we are still dealing with two functions. They're defined above. U of x equals 3x minus 2, and W of x equals x squared plus 5. This time we're doing the composition of these two functions. So part A is the composition of u and w evaluated at -5. When you're given an actual number, you work inside out. So you first evaluate w at -5. So take the function w, plug in -5 for x, and do the calculations. -5 times -5, that's a positive 25, plus 5, that's 30. Now that you dealt with the inside function, you need to do the outside function. So that's u, and that one will be evaluated at the number we just found, so 30. Let me make a note of this. So now the function u, that's 3 times 30 minus 2. So that's 90 minus 2, which is 88. And that is the final result. That is what you box in. 30 is an intermediate calculation. We don't box it in. Now part B, it's still a composition of two functions, that little circle in between, that's a composition of two functions, no multiplication, but this time it's evaluated just at x, not at a number. So this can also be written as w composed of u composed of fx. Okay. So what does this mean? That means take the inside function, which for us is 3x minus 2, and plug it in where you see the x in the outside function. So for us, this is going to be 3x minus 2 squared plus 5. Now you have to square, you have to simplify it completely, so you have to square 3x minus 2. Again, recall that this is the same as 3x minus 2 times 3x minus 2 plus 5. So that's 9x squared. 3 times -2, that's -6x. Then -2 times 3x, that's another -6x. And then -2 times -2, that's plus 4. And then we have this plus 5 that's just kind of hanging out. We have to combine like terms in between. So 9x squared minus 12x plus 9, 4 plus 5. So that is the final result for the composition of w and u, which is evaluated at x. All right, graphing. So you're given the graph of a line, you need to find the slope and then answer a couple of questions. The slope of this line, the easiest way to figure that out is to just count. So to get from this point to this point, we have 1, 2, 3 down. And 1, 2, 3, right? Down is a negative direction, so this is -3/3 or -1. Find f at -2. Okay, let me erase this. F at -2, so function value at -2, you need to remember that this is the x value. You're looking for the y value. The function value is the y value. So find -2 on the x, that's right here. Then go up or down, depending on where your graph is, until you hit the graph. For us, it's up. Once you hit the graph, see what the y coordinate is that corresponds to that point on the graph. And for us, the y coordinate is 5. Find one value of x such that f of x is -1. Well, this time, this is y. Y equals -1. x is, we don't know. We need to find it. So go to y equals -1. That's right here. Go left or right until you hit the graph. For us, it's to the right. And then see what x coordinate corresponds to that point. And that would be 4. Number 15, another word problem. The height in centimeters of a candle is a linear function of the amount of time in hours it has been burning. When graphed, the function gives a line with a slope of -0.6. Suppose that the height of a candle after 12 hours is 18 centimeters. What is the height of the candle after 15 hours? Okay, so the easiest way, not the only way, but the easiest way to me to approach this particular question without actually doing the reiterative subtraction would be to use the slope formula. So m equals y2 minus y1 divided by x2 minus x1. In order to use the slope formula, we need all of these letters filled with numbers except for 1, and then we can actually solve it. Well, m equals -0.6. That's given in the problem for us. We are also given some points. If you look at the graph, the first point that we're given is 12 and 18. 12 on the x, 18 on the y. The second point that we are sort of given is in the question. What is the height of the candle after 15 hours? Hours is my horizontal axis or the x-axis. So 15 on the horizontal axis and y2 on the y-axis. That is our unknown. Everything else is known. So on the x and y coordinates, this is x1, this is y1, this is x2, and of course this is y2. Now we can plug it all in to the slope formula and see what happens. So put it all together. -0.6 equals y2 is unknown minus y1 is 18 divided by x2 is 15, x1 is 12. We'll go ahead and subtract the values in the denominator. Now, multiply both sides by 3 to get rid of the denominator. So -1.8 equals y2 minus 18. And then to calculate y2, you're just adding 18 to both sides. So -1.8 plus 18 is your y2. And that would be 16.2 centimeters. Would be the height of the candle after 15 hours of burning. Sixteen, we're doing the average rate of change from the graph. Okay, let's figure out from x equals -5 to x equals 4. X equals -5, that point is right here. X equals 4, that point is right here. I'm trying to find the average rate of change between these 2 points. Since we're given the graph and the points are on the intersection of 2 whole numbers, the easiest way to do this is just using the slope formula that's rise over run. So from this point to this point, how many squares do I have to go up? 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 9. And then how many squares do I need to go to the right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 again. Up is a positive direction, so it's just 9. Right is a positive direction over 9, so that's just 1. Number 17, for each relation, decide whether or not it is a function. So on the very first one, we have a bit of a dilemma. So both J and V are going to two different things on the range column. That cannot happen in a function. Domain or your X values should only go to one specific Y value, otherwise it's not a function. So no, this one is not a function. The second one, domain H, N, and Y, and the range is tree. Well, the range can have repeats. It's not an issue. The domain has all values that are non-repeating. They're all unique values. So yes, this is a function. Now on the last one, you need to just look at the X coordinates. The Y coordinates can repeat, so we're kind of ignoring them. You're looking for X coordinates that are not repeating. I have Z, H, G, and K. They're all different letters, so yes, this is a function. Number 18, you need to find the slope and a point on the line and then use them to graph the line. This is a point slope form of the line. The point slope form looks like this: y minus y1 equals m, x minus x1, where point on the line would be x1, y1, and m is, of course, the slope. So let's start with the slope. It's the easiest one. The slope for this line is -1/4. Now the point on the line. If I take this and rewrite it as y minus a -4 equals -1/4 x minus a -2, I'm hoping that that will make it clear that y1 is a -4 and x1 is a -2. So the point on this line is actually -2, -4. To graph it, you plot the point first. So you plot this one first. -2, -4, -2 on the x, -4 on the y. That's right here. And then you do the second point by using the slope. The slope is -1/4. So it's rise over run. And we're going to go down 1 because negative direction is down, and then right 4. Now you do not want to do down 1 and left 4 because both down and left are negative direction, and negative divided by negative is positive. And we want the slope to be negative. So let's go ahead and plot. So down 1, 1, 2, 3, 4. Here's 1. Down 1, 1, 2, 3, 4. Here's another one. And again, to just draw a line, you have to connect the dots with a straight line, or as straight as you can. Number 19, we need to figure out by looking at the graph whether it is a function or not a function. This is a vertical line test. So if a vertical line passes the graph more than once, it's not a function. So the first graph is a function. The vertical line, no matter where you draw it, will only pass the graph one time. The second graph is not a function. There's lots of spaces where it breaks, but here's one that's pretty obvious. The vertical line graphed at that spot on the function actually passes it twice. So this graph does not represent a function. When you're given a bunch of points, what you need to do is look that every point has its own vertical line, and it does here. So this is a function. Number 20. We need to find the average rate of change for the distance driven from 4 seconds to 10 seconds. So the average rate of change is the slope. equals y2 minus y1 divided by x2 minus x1. Okay, my x's are times on this one, and it is from 4 to 10. So this is t1, this is t2, which means this is d1 and this is d2. So for us, this formula will look like this: d2 minus t1 divided by t2 minus t1. d2, 239.6 minus 166.4 divided by t2, which is 10, minus 4. Calculate it out, that's 73.2 divided by 6, or 12.2 meters per second. That's the average rate of change from 4 seconds to 10 seconds. And the last one on this review, we need to state the intervals where the graph is increasing, decreasing, or is constant. So on these intervals, you need to remember that we are just looking for x values and we're only using parentheses. I'll put it on the side. Okay, we'll start with the intervals where the function is increasing. There's only one of them, and it is right here. X values only, so this is from -7 to -5, parentheses only. Now the next one is the intervals where the function is decreasing. There's two of those. One right here and one right here. So you start with the leftmost point, which is -1 on the x. -1 to 2, left to right. That's the first interval. Then you unite it with the interval from 3, x values only, to 5, parentheses only. Then we also have the intervals where the function is constant. And that's where the function doesn't change in value. That's this interval right here and this interval right here. Left to right, smallest to largest, -5 to -1, united with the interval from 2 to 3.